1a part I, state Hess's law in the reaction. The enthalpy change for a chemical reaction is independent of route taken. Part 2 is a Hess's law problem where you have to calculate the enthalpy of the reaction using delta HF data. Delta HF data means the enthalpy of formation of compounds data, which means you need the elements at the bottom of the cycle. The arrows move upwards towards the compounds, and the corresponding enthalpy changes are listed in the table. So the enthalpy change of formation of manganese oxide is minus 971 kilojoules per mole. There are 3 moles of carbon monoxide being formed, so it's 3 times 111. And on the other side, there are 3 carbon dioxides being formed, so 3 times minus 394. We must take into account these molar amounts. There's no value for manganese dioxide because, by definition, the enthalpy change of formation of an element is 0. So then, this is the direct route, this is the indirect route, so we have to switch the arrows around and switch the values around, and you can see I've written that in green on the left hand side. So the minus 971 becomes positive, minus 333 becomes positive 333, then add the 1304, minus 1182, that arrow is going in the correct direction, there's no need to flip that, and we get to plus 122 kilojoules per mole. You should write the elements here in full, in their standard states, as written there. Part 3, already talked about this. Why is the formation of manganese dioxide 0? By definition, the enthalpy of formation of an element is 0. These questions here is detailed knowledge of metals, metal extraction. So titanium 4 oxide means it's a plus 4 charge. So TiO2, remember, oxide is 2 minus. Chlorine, Cl2, and carbon extract titanium from its ore, leaving you with titanium chloride. TiCl4, that's a minus 1 ion, that's a plus 4 ion. 2 carbon monoxides is the other product. CO2 is also okay. You can have CO2 instead of carbon monoxide. The second stage of the extraction is with sodium. Again, learn the details from this in your notes. So titanium chloride, plus 4, remember, minus 1, plus 4 moles of sodium gives you titanium metal, and then 4 moles of sodium chloride, that's 1 plus, that's 1 minus, hence NaCl. Mg is also okay for that reaction as well, but it would be a bit different balancing. Check out your notes for that. Then we come to this equation. Balance the ions first. We can see that the ions have already been balanced with the number 2 in front, which means we need to have 4 ions on the left hand side. Next, look at chromiums. Chromiums is there, that's been balanced with the number in front. That's 8 there, so 8 in front of the sodium dichromate. Then we'll look at sodium. There are 16 sodium there. Go back and put the 8 in front, so that's 8NO2CO3 there. And now the oxygens. If you count these oxygens, you'll find it comes to 54. In these compounds, it comes to 40. So 7O2 means the extra 14. In this question, reduction with aluminium, what you've got to consider here is the formula of aluminium oxides. It's Al2O3. Aluminium is a 3 plus charge, oxide is a 2 minus charge. So write the formula of aluminium oxide. Chromium oxide you've been given be 2Cr because it's a metal, not Cr2, 2Cr to balance, and then 2Al is the last part. So in 1D we asked the type of reaction that iron 3 oxide undergoes in the extraction. Well, if we're extracting a metal, we're going from an iron to a metal, so it's 3 plus to a 0 oxidation state, so it's a reduction. The gain of electrons, so reduction. The half equation, well, it's iron 3, so Fe3 plus is being changed to iron, so plus 3 electrons gives us the correct half equation. So it's 3 plus 3 charge on the left hand side, 0 on the right hand side, so plus the 3 electrons there balances the sides. This next question doesn't really fit in particularly, but it's an important definition. The enthalpy change, the standard enthalpy change of combustion, the enthalpy change when 1 mole of a compound is completely burned in oxygen with all reactants and products in their standard state. The key terms have been underlined. This next question is about kinetics. You're asked to state the meaning of the term rate of reaction. Well, we've always got to consider it's the change in concentration of a substance over the change in time. And I've written the description there. Now if you look at point W, you can see that there's no further hydrogen being formed. Remember when you're measuring the rate, you take the gradient, the tangent, and you take the gradient of that tangent. Now that tangent here would be 0, so the rate is 0. And why has that happened? Well, the magnesium has all reacted. How do we know it's magnesium has all reacted? Well, it says that the magnesium has reacted with an excess of dilute hydrochloric acid, so it's therefore correct to say that all the magnesium has reacted and not the HCl. That is in excess.